Always true. Always true. Always true. Always true. Always true. Always true.
Good afternoon, everybody. Hope you guys are doing well. Let's, oh man. Come fast, yo. This is not soon. The fuck it isn't. It's always soon. It's as soon as it is. Ugh. Today we're going to be doing arrays in C++. I have no idea exactly what arrays is going to entail. But it's sure to be interesting. And this section is apparently an hour and 6 minutes long, so we're gonna see how just how bad that, how difficult that is for me, just how bad that is. Because no, if the section is an hour long, then I'm probably gonna take 2.5 hours or some shit. It's gonna be insane. Because I'm stupid. Arrays of sunshine, hell yeah, man. Now, from what I understand, arrays are gonna be very useful and very helpful. And the chapter after this is pointy. It's easy only why? I don't understand what you mean. Let's see. Let me open my shit. Open folder. Have I done this? Okay, so I have not done this one. copy the contents of... gotta copy the contents of my frickin' folders. I'm awake. How you doing, Tara? Why are you insisting on being an asshole, kitty cat? Deciding that right now you want to scratch my chair. You're like, oh man, I already annoyed you earlier today when I was interrupting your recording, but no, now I have to be annoying for all situations at all times. Why are you like this, huh? Alright, got my shit sorted. Let's go. Reveal your face? Fuck no. Why the fuck would I want to do that? That's retarded talk right there. Alright, let's go. Time to draw a farmhouse porch filled with veggies for chapter 1? Hell yeah, man. Let's go. Code. Let's get our shiznit all sorted out. Yeah, I can get rid of all of this. This is a copy. None of this is important. Alright, let's get going.
In this new chapter, where we're going to be learning about arrays. And arrays are a way to set up collections in our C++ program. So far, we have been working with single variables. For example, you have a bunch of integer variables. You can even have 10 or 20 variables of integer type, and that's going to be fine. But sometimes you don't want to manage all these variables. It is really desirable to group all these variables into one single unity and manage them as one single entity. And we can do something like this, group them together and give them a name so that we can refer to them or manipulate them under this name here. And C++ has the array construct to help us do this.
Is this going to be like matrices?
If you look in memory how things are laid out, you're going to have a bunch of zeros and ones. For example here, each red thing is an int. It is 4 bytes in size, and it can be used to represent an int. So if we have a bunch of events like this, we might want to group them together and give them a name and manipulate them under this name. This is another way to look at what we just talked about here. And again, arrays are a way to do these kinds of things in C++, and we're going to be learning all about it in this chapter. We are going to stop here in this lecture, and we are going to start and look at how you can declare and initialize an array in the next lecture. Go ahead and finish up here, and meet me there. In this lecture, we're going to see how we can declare and use arrays in our C++ program. And again, arrays are a facility we have in the C++ programming language to group many variables together and manipulate them as a single unit. For example, here we have a bunch of integers in memory. Each of these red things is going to be 4 bytes in size, so we can think of it as an integer. And we can group them together and give them a name. We call them scores here, and they are going to be living under that scores entity. So if we want to refer to each of these things, C++ provides an indexing system, so we can use angle brackets like this and refer to the first of these integers as 0. So we can go from 0 all the way to 9 here, but your array can even be bigger than this, many times bigger than this. And we're going to see examples of how we can do that. But this is an example of how you can take many variables, group them under one entity, give them a name, and be able to reference each of these things that are under that entity. And now that
I remember
the
being
idea
really
is
bad
pretty
at
clear,
matrices.
let's see how we can do this in C++.
Math when I was in high
The way to do that is to say int. You have to specify the type of your collection. You have to specify the name after that, and then you're going to put a pair of angle brackets like this. And inside those angle brackets, you can specify the size you want that collection to have or that array to have. And after this statement is run, we're basically going to have something like this in memory. We're going to have 10 integers. So if you count here 0 all the way through 9, that's 10 integers. They're going to be grouped together under one logic entity. That logic entity is going to be called scores. And we can go through that name to manipulate all these things that are in this entity. Okay,
You'll
after your
rarely do math
array
with them,
is
thank God.
declared and you have space for it in memory, basically something like this, we need a way to read data from it. And we're going to see how we can do that. And it is what we have here. For example, if we want to print the first of these elements, we're going to say scores, angle brackets, and specify the index of the first element in that array or that collection of integers that is called scores. Okay, one thing you should really keep in mind is that arrays are indexed from 0. They don't start from 1. So the first element is going to live at index 0. It's not going to live at index 1. So here scores 0 is going to print the first element, and scores 9 is going to print the last element, which happens to be the last in our collection here of integers. Okay, once our array is declared, it's not going to have data in it. There is going to be data in, but it's not going to be data that we put in. So we can think of this data basically as garbage. Another thing I want to bring to your attention is that your array has clear boundaries. When we declare an array like this, notice that we specify 10 as the size of our array. It's only going to have 10 elements inside. And you can see that we have from index 0 all the way to 9. And inside we have garbage data, but we're going to fix that in a minute. What I want you to see here is that you can't try and read outside the bounds of your array. C++ is funny in that it allows you to do that, but if you do that, you're going to get weird problems. For example, your program would crash or do something really bad, so you shouldn't really do this. Be aware of the boundaries of your array. If you try to read data from the outside of your bounds, you may read garbage data. You may even cause failure of the operating system because you don't really know whose memory you're reading.
Wait,
it's not
what?
going to be
Failure of
memory
the
that is
operating
allocated
system?
to your program. So array boundaries are
Does
something
he mean
you
that
need
it's
to
going
keep
to
in
crash, or is
mind
like my whole
when
shit
working
going to
with arrays.
get
Okay, we
destroyed?
just saw that we could read data from the array using this angle bracket syntax. We can even do that through the loops and read all the elements in the array. And this is how we could do that. And you can see that the loops we learned about in the last chapter are starting to come in handy. Okay, we have seen how we can read data from the array, but what if we want to put something back in? What if we want to write our own data in an array? Well, the syntax is pretty much what you would expect. We also use this angle bracket syntax, but we're going to assign data to that element in the array. For example, if we want to assign data to the first element in our array, we're going to say scores, angle brackets 0, and we're going to assign a 20 in it. And we can assign a 21 into the element at index 1 and a 22 in the element at index 2. And if we do that, we're going to have something like this in our array. So index 0, we have a 20. Index 1, we have a 21. Index 2, we have a 22. And the rest is still garbage because we didn't put in our data. We can also write data in a loop. For example, here we have our array declared, and we're going to loop around putting data at different indexes. Notice that the index is going to be the current iteration we are at. So this is a common way to do things in C++, and you need to be familiar with this. And after we put in the data, we can read that back and make sure that it is the actual data that we put in. And we're going to have a chance to play with this in Visual Studio Code in a minute. So don't worry if some of these things don't make sense.
Yeah, I kind of want to
yet.
see what
But
this
again,
looks like in
the
practice,
main thing
because
here is this
I think
angle
I'm having a
bracket
little trouble
syntax. We can
understanding,
use that to either
but I don't know
write
exactly
data
what I'm missing.
in the element
What did
of
I
the
miss?
array or
Just
read
writing
data
stuff
from
into
the element
arrays.
of the array. And this is the syntax here, scores angle brackets I. Okay, so far our array has been declared and we didn't really put in data and there was junk data inside. But there's a way you can declare an array and put data in one single statement. And this is how you would do it. Here we have another array. It's going to be grouping double variables. We call the array salaries and we specify that it's going to be of size 5. And we can put these elements in a comma separated list using braced initialization like this. And it is going to work. If we try to print it out.
Okay, so just to make sure I'm kind of understanding this. So this, with double, it's instead of creating n integers, we can use array to create n integers with a single name assigned to those group of integers. Okay. So my understanding then of this, right? So we're using double here because we're storing a bunch of double values. The salaries is the name of the array. 5 is the number of things that we can have inside of our array. And then these are the actual numbers inside the array. So salaries 1 is this. Salaries 2 is this. Salaries 3 is this. Salaries 4 is this. Salaries 5 is this. Yep, okay. And then for here, what is this? So it's a for loop. So for size t I 0, salaries I. Well, I guess this would be 0. And then it goes up to 4 and then 5. Yeah. So then for I 0, so then this writes out 12.7, 7.5, 13.2, 8.1, and 9.3. So salary 0 is the first value of 12.7. Yeah. Arrays start at 0. Yeah. Yeah. That was that makes sense because I mean I guess that's why this starts at 0. Okay. I think I'm understanding better now.
We're going to see these elements here, and you see that we can read
A little
this
bit less
using the same
worried about
syntax
that.
we've learned about salaries. We say the array name, we do angle brackets, and inside we put the index of the element we are reading from, and this index is coming from our loop here, and it is going to work. You're going to get these elements printed out. This is pretty cool. When initializing your array,
That's actually
you can
like,
leave out elements. For example, here we have an int array.
useful.
It is called families. It's going to be of size 5, but we are just putting
I
in
can
3
explain
elements.
why that is, but you still
The
haven't
rest
learned
are going
pointers.
to be
Yeah, that's the next
initialized
chapter.
to 0 when we do things like this. And this is something you need to be aware of. And we are going to try this out in Visual Studio Code, and you're going to see that this is actually true. It is possible to also omit the size when you are declaring your array, and the compiler is going to deduce the size from the elements that you initialize your array with. For example, here we have in 1, 2, 3, 4, 5, 6 elements. This array is going to have a size of 6. And if we print elements, we're going to get those printed out.
You're going to show me the
here that
wildest
we
thing.
are using
Oh,
a ranged-based for loop, and hopefully you can see that it is easier to read data from a collection like this using a ranged-based for loop, because we don't have to set up an iterator, initialize it, do the test, do the incrementation. We can just read the value and use it and be on our merry way. This is pretty cool. It is possible to also declare your array constant, and when you do that, you won't be able to modify elements of that array. That's what it means if you make it constant. You basically want it to stay constant, and you don't want to allow modifications of your array. And we're going to see this in a minute when we get in Visual Studio Code. The last thing I want you to see is that you can actually do operations on the data that you have stored in an array. For example, here we can sum the elements up and store the result back in our variable sum. And this is something you would do, and it might come in handy in many times. Okay, one thing I want you to see before we head over to Visual Studio Code and play with us is that arrays store elements of the same type. Repeat after me. Arrays store elements of the same type.
Arrays
you can't
store
try
elements
and store
of the same
variables
type.
of different types in an array. I don't even
So they
know
all
how
have
you
to
would
be
actually
integers,
declare that.
all
And
doubles,
if you try and store a
all
different type
of
than
one
the type that
type
was declared
of
for the array, you're going to get a
thing.
compiler error. So this is something you should keep in mind, but it makes sense because when you declare an array, you're going to be given a bunch of bytes in memory, and those bytes are going to be collections of data that is of the same type. For example, here we have a bunch of integers. Again, each of these red things is an integer. And if you try to put in something that is smaller or bigger than an int, then the compiler is going to be confused as to how to read these things. So for arrays to work, the types that you store in the array have to be the same, and they need to be consistent. This is something you should know, and if you try to break this rule, you're going to get a compiler error. Now that you know about arrays, we're going to head over to Visual Studio Code and play with them a little bit.
All right,
okay,
let's get
here
some
we
practice
are
with these
in
things. I have no
our
idea
working folder. The current
what all
chapter
we're gonna
is arrays.
do
The
for
current
this.
project is declaring and using arrays. We're going to grab our template code, and we're going to copy and move the files over. And we're going to open this thing up in Visual Studio Code pretty quick. We're going to open up the main CPP file and remove things we don't need. And we're going to see how we can declare an array of ints. Okay, the way you do that, you say the name of the array and you put these angle brackets and specify the size of your array. If you want, you can put a space in here. It's really not going to make a difference. And you're going to put a semicolon at the end. The moment this line executes, we're going to have the space for 10 integers allocated to us in memory, and that space is going to be called scores, and we're going to be able to read data from it or even write data back into it. For now, let's see how we can read data. And it is really simple. We're going to use this angle bracket syntax that we just saw in the slides. So if we want to read the first element, we can say stdc out. We want to print it out, and we're going to say scores. Specify the index we want to read from, so we say 0, and we're going to say std.endl to move to the next line. If you have this typed out, you're going to see that this is going to work, and it is going to print whatever is stored in the first element in this array here. And again, I want you to keep in mind the memory structure of your data when you are working with arrays. So what we're going to print right now is whatever junk data is in this first element here. Okay, in here we're going to say that we have in junk data. And let's bring up a terminal so that we can play with this. And we're going to build this with GCC as we always do. The build is going to be good. And we're going to clear and run rooster. You see that this is the junk value we have in here. We don't have any useful data in here. It's just junk data because we didn't initialize this array. We can also read the element at location 2 and see what we have in there when you run the program. I'm not even sure if it is guaranteed that you're going to get the same data if you run the program multiple times.
Let's try.
But we don't really care. We know that it is junk data. So we can't use this in our program. What we're going to do is run this and see the value for the element at index 1. Let's build with GCC. The build is going to be good. We're going to clear and we're going to run rooster. And you're going to see that at index 1, we have a 0 end. But doing it manually like this is really time consuming. And it is possible to actually do this in a loop. We know the size of this array,
it's the garbage
so
I told
it's
you about.
10, and we can loop around 10 times, printing each element at each iteration. And the way we do that, we're going to read with the loop, and we're going to say for, okay, size t, and we're going to start from index 0. This is really important because arrays are indexed from 0. They don't start from 1 again. This is something you need to drill in your brain. And we're going to put in our test case, we're going to say I less than 10 because we want to go from 0 through 9. And we are going to increment our iterator. After we do that, we're going to have to jump into the body of the loop. And we didn't name our iterator. That's why we're having this squiggly line here. Let's do that pretty quick. We're going to jump into the body of our loop. And we are going to say stdc out. And we're going to say scores. And we need to be careful about how we format this because I is not something we have. We're going to be getting that from our iterator here. So we're going to print it like this, and this is going to work. No big deal. And we're going to say scores, and we're going to say I. That's going to be our index that we want to print the data for. And we're going to say std.endl. And because we don't want this to confuse us, we're going to comment that out.
And I hate the way this text thing is formatted.
And make sure our comment is nice and neat. And we're going to try and run this. And what do you expect to see? Well, we don't have any real data in here. We're going to have some junk data. So it could really be anything.
It's going to be 10 different lines of junk data.
So let's build with GCC. And we're going to give ourselves some breathing room. We're going to go down and clear and run rooster. And you see that, this is really some junk data.
I don't know why he's doing size
and if
T.
we run it again, let's see that we get the same output. It is the same data in here. If we want to have in some reliable
These
data,
are the ones from the
we
loop.
need to write
This is
in
the
our own
stuff
data.
that we
And
did
we're going to
before.
see how we can do that. We're going to see how we can write data into an array. And the syntax is really simple. So the way you do that, you just say the index for which you want to write data in, and you say scores, and you specify the index, let's say 0, and we're going to put in a 20, for example. This is how you do this. You say 20, let's say scores. We're going to grab
I feel
the
like
index
this is
1,
gonna
the first
be
element, and we're going to
replaced
put
with
in
a
a
loop
21.
as well, maybe?
Why not? And we're going to say scores. We're going to say 2 for index 2, and we're going to put in 22. Why not? And after we do this, we can print this out or read data with the loop and make sure that the data we did write in is actually in. So we're going to copy this and comment this out because we don't want this to confuse us on the console. And we're going to do that. We're going to come down here and print the data out. Let's say what we're doing here. And if we build this, we expect to see that at index 0, 1, and 2, we have the values 20, 21, and 22. Let's build and see. We're going to run the test to build with GCC. The build is going to go through. We're going to clear and run rooster. And look at this. Score.
Okay, let me catch up. Let me make sure I'm. So it's these. We have the exact same text here. I'm actually gonna go ahead and increase this up to. I'm gonna comment this next part, this top part out as well, because I don't really need these 2 lines. I don't think. Why don't you array some maidens? You know I would. Let's see. Run task G++. Clear rooster. Well, we got these 3. So that's the ones that we want. Those are the ones that we actually input data for. These other ones is just random numbers. Kind of hilarious how random the numbers are.
Score is 0, 20, score is 1, 21, score is 2, 22, and our data is actually getting in. Now we're going to see that we can also write the data using a loop to make it really easy without us manually doing things like this.
Yeah, this seems.
For that, we're going to copy what we have here to print data out, and we're going to comment what we had out here. So let's comment this out, and we're going to go down and print the data again. We're going to put in the code here, and before we print the data, we're going to put data in with the loop. So the loop is basically going to be the same thing. We're going to say size ti. We're going to initialize this. We're going to say I less than 10 because we want to loop 10 times. We're going to increment, and we're going to fall in the body of the loop. What we're going to do is write data at the index of the current iteration, I should say. So what we're going to do, we're going to say scores I, and we can really put in anything. For now, let's say we want to put in I multiplied by 10. So we're going to take the current index, multiply it by 10, and we're going to store that in the index at the current iteration. This is what we are doing here. And if we print this out, try to think about what we're going to get here. So at index 0, let's put in a 0 to be super clear here that we are starting from index 0. At index 0, we're going to take 0 and multiply that with a 10. So we're going to store 0 at index 0. The loop is going to run again. At index 1, we're going to take a 1, multiply with 10, we're going to get a 10. At index 2, we're going to multiply 2 with a 10 and store a 20 at index 2. And we're going to keep going and basically have 0, 10, 20, all the way to 90 stored in our array here. So if we print it out, we expect to see 0, 10, 20, all the way to 90. Let's build and see that that's actually what we have in our array. We're going to build successfully. Let's clear and run rooster. And you see that this is exactly the same thing we have in.
I'm working on the panel where the veggies try the first stitch they make in the story. Garlic gnocchi? I don't know how to pronounce that word. Iterating beyond the bounds of lands you... Beyond the bounds lands you in undefined territory because it's not reserved. It's data from your RAM. Also, hello, gnocchi. arrays are very convenient. This does seem very convenient. Because, like, before, what we did, we just kind of printed a shitload of lines. We printed 1,000,000 lines of text. What if I... What if... No, I'm not doing it again. Not up to 1,000,000 anyways. That took like a couple of minutes of printing. That was pretty funny. Wait until you find out about vectors. Roger, what's your vector, Victor? Nochi is like pasta you make with potato. Ooh, that's convenient. Everybody loves pasta. Everybody loves carbs. Carbs are delicious. Like this is the thing where he said print data out. I know technically I don't have to do that, but I'm gonna say so. Write to array with a loop, because we did. Because like this was writing it into the array. This is reading it with a loop. This is combining those two things. Feels like Mike Tyson's knockout. Nice.
In our array. How cool is that? Okay, another thing I want you to see is that we can declare and initialize an array in place. But before we do that, let's say
what
we were doing here. We were trying to write data in a loop, and we're going to comment this out because we don't want a lot of confusing output in our console. And we're going to go down and put in the data because I don't want to type all these things. So we can declare and initialize.
Hold on. Let me... What the hell? He just copied in all of this? My god. That's not fair, man. I have to actually write this shit. Alright, let's see. std cout. std and L. I don't know why he has an empty line there. Declare and initialize at the same time. And how? Double salaries. Oh, so now we're using a different array. So I call this one 5. And it's 12.7, 7.5, 13.2, 8.1, and 9.3. And then we're doing 4 size T. Oh, wait, I fucked up. 4 size T I. And we're gonna have that at 0. I is less than 5. And then we're doing iterate. And then we do like so. And we have to print out a line for std cout. Salary. And then it's this. This really awkward format for our text that I hate so much. I understand why he's doing it that way. It's so that it shows up all nice in the terminal, but like 2D arrays will be fun. Oh god. Do we actually get to those today? That feels like it'd be really, really complicated. I mean, this hasn't been too bad so far, right? But we're also only dealing with one dimension. Like, I remember struggling to understand, like, I think it was multiplication with arrays. Like, adding with arrays, I don't remember being too bad. Or not arrays, matrices. Adding with matrices wasn't too bad, but I feel like multiplication was something that was more complicated. And I don't remember exactly... I don't remember the lessons, so I don't know what the fuck... how much worse it'll be. Get used to writing like that. Better than printf. It's just an array of arrays. That doesn't make it sound better. That It's an array of arrays. Oh yeah, great. Let me just nest my arrays, I guess. Printf is nice for debugging. Well, you're not going to use them for math unless you're an AI programmer. Oh god. Look, my programming is probably never going to going to be that complicated. We'll see. We'll see where the future takes me. But for now, I'm not expecting it to be like, oh yeah, I'm gonna get into the most advanced shit ever. An array is a book. An array of arrays is a shelf. I'm afraid AI is the only programming where you have to calculate with matrices. If you say so, man. I'll take your word for it. I mean, I don't know. I just know that I'm afraid of matrices.
An array in place. And the way we do that, the array is going to store doubles now. We can really declare an array of anything, but so far we had seen that we can do that for int. Now let's try a little bit and show you that you can do the same thing for double types. So we can declare an array of double types. The size is going to be 5, and we're going to initialize that with this data here. So at index 0, we're going to have a 12.7, index 1 a 7.5, index 2 a 13.2, index 3 an 8.1, and index 4 a 9.3. And that's what we're going to have if we print this out. Here we have a simple loop to print it out, and it's going to basically say salary 0, 12.7, and it's going to go all the way to salary 4 and print a 9.3. So and this is something you can do if it makes sense for whatever you are designing with C++. We're going to build this with GCC. Let's clear and run. And you see that this is exactly what we expect. Okay, now this is super clear. The next thing
so this line here, the declare and initialize at the same time, I must have missed when he changed that to a comment. But we had it here in text because that's the way that it was before. I mean, fuck it. That's whatever. I must have missed that.
The thing we're going to see is that if you don't initialize all the elements in the array, those you leave out are going to be initialized to 0. And we are going to put in a piece of code to play with that. So here we have an array. It's an int array. It's going to be called families, and the size is going to be 5. But we are only initializing 3 elements. And these elements are going to be elements on the front. So elements at index 3 and 4 are going to be left out, and they are going to be initialized to 0 by the compiler. So if we print this out, we expect to get 12, 7, 5, and 0, 0 at different indexes in this array here.
Wait, if we don't initialize all elements, those you leave out are initialized to 0? But, like, I thought it was the junk data. I was kind of under the impression that it was that if we didn't initialize it, it would give us junk data. Let's see. Let me go ahead and move this down again. Let's put in what he has. Int families 5 12 7 5. Then we do our for I 0 I less than 5, and we iterate, do this, and we want to print, and then it's families, and then we have to bit shift, and then we do I again, bit shift, this, and then we do families, I, like so. Arrays are crazy in Python because it could be made up like 2.47 Bravo car get object, and it's valid. Are you insane? Wait, what? Are those not all different elements? I mean, I could see 7 being stored as like a double or something like that. Or is the arrays have to be made up of the same object, a C++ thing, or the same thing? I guess it was like integers, doubles, stuff like that. I guess Bravo could technically be a variable of some sort that's being used. Car get object seems like something else though. Completely different data types, but Python be like that. What the fuck? What do you mean? I'm having a hard enough time. I have a hard enough time wrapping my head around like, oh yeah, we're gonna use multiple numbers at the same time, and not like. Wait, why is this not? Oh, I don't have my C out. Our family's I. Okay. So the way that he's explained this, he said in the comment we see up here, it says if you don't initialize all elements, those you leave out are initialized to 0. But I was kind of under the impression that when we didn't initialize them, like when we did it like this, it seemed like the scores were initialized as junk data, and I didn't kind of I didn't I don't really understand how that affects or why it would become 0 if I do it like this. Python is super easy to learn, but it kind of makes learning more low level, like C, really difficult to adapt to. I mean, yeah, the reason that I'm going with C++ is because my ultimate interest is game dev, and fucking I've messed around with Unreal, so I figured if this goes well and it's popular and I enjoy doing it, then I might go into doing some Unreal tutorials. But I needed a foundation to stand on, because when I messed with Unreal before, it was very helpful and I was able to do some things that I wanted, but I didn't understand the code or why it worked the way that it did. I didn't feel like I had a good grasp on it. And I was told that C++ is good for programming fundamentals. So, and it would be easier to transition to use like C# and like Unity and the like as well. All right, did I build this? I did not. Let's build it real quick. Let's just see what it does. Because my understanding... So this is interesting. I don't understand why it's initializing to 0. Maybe Sensei Gakwaya will tell me.
Let's build this with GCC. We're going to clear because the build is successful. And we're going to run this. This is exactly what we expect. We have a 12, a 7, a 5. And the last 2 elements are initialized to 0. And this may come in handy sometimes. Okay, let's comment this out. Another thing we want to see is that we can actually omit the size when we are declaring our array and initializing it. So here is a simple example. We have an int array called class sizes. We don't specify the size, but we initialize it. And the compiler is going to deduce the size of this array from the elements we put in here. So if we put in 2 elements, so it's going to be of size 2. If we put in 10 elements, it's going to be of size 10. And this is how this works. But if you do something like this and not initialize the array, let's take this out, for example, you're going to get a compiler error because the compiler now doesn't know which size it's going to give to this array. So be sure to either put in the size or initialize your array like this, and it is going to work. In this case, we're going to have 6 elements in, and you see that a ranged-based for loop is going to come in handy here because we don't really know the size of this array. If some
zeros, because that data space is reserved and computer clears the values. As long as you give any value while initializing an array, it fills it with zeros. But even if you do int array equals int 10, int array 10 equals, and then nothing. So if we do it like that, it initializes essentially 10 instances of 0, like one in each of the array slots, right? So why did am I misremembering? Did doing this not fill the rest of it with junk still? Or is this like is it because this thing is like it's not initialized in the array or something? Because that's not initialization. Oh. What do you call this then? I mean, it's not initialization. So that's assignment. Okay. So because the array didn't have any values initialized. It had them assigned. That caused the rest of it to still be junk. Okay. Okay. You initialized it when you did int scores 10. Well, but this was the one, wasn't this the one giving us junk data? Bro now understands the assignment. I hope so. Dude, this is one of the things that I'm like I don't really I'm not super familiar with. So essentially initialized array with no initialized values is a junk array with junk data. If you assign values within that array, it doesn't initialize them. It's not it's kind of a you just kind of change one thing and you would have to go through every single one to do it that way, right? But if you do it like this, you initialize the entire array and it gets filled with zeros as placeholders, essentially. Exactly. Okay. 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 I'm understanding. I can feel my brain expanding a little bit. You know. I can feel it. Okay. Let's see. So we were gonna move this further down to here. Let's take a look at what this next one is. So let's omit the size of the array at declaration. So this is where we're doing class sizes. So this is where we don't write in anything there. 10, 12, 15, 11, 18, 17. And we do, we'll print this with a range-based for loop. For auto value class sizes. This is why I mainly stick to food. I mean, you can do both. std cout value. Welcome to the circus of values. All right, so I don't know if we'll pring this. Yeah, we'll pring it. No big deal. So here it's just going to assign what? 1, 2, 3, 4, 5, 6 values. 6 slots to this array. So are you a high school student? No. No, I've been out of high school for a while. I'm just kind of an idiot. I haven't had to do math in so goddamn long. And so the beginning of this was kind of like, oh man, I have to do multiplication again. But this is the way that it is. That's it.
Somebody comes and adds in another element, let's say 23, the size is going to change, And if we hard code the size in our for loop, the code is going to break. But a range-based for loop is going to use whatever size this array has. So we're going to try and build this. We're going to build with GCC as usual. And the build...
You're not an idiot for those reasons. You're right. I'm an idiot for other reasons, but the fact that I'm an idiot remains the same. Working on a full page panel of veggies and human introducing themselves. Nice. Let's see. I kind of want... Wait. What am I doing wrong? Auto value. Class sizes. Let's build this. It built fine. What am I doing? So this is our array. This will print with a range-based for loop. So auto value. Wait, what the fuck is value? Hold on, I gotta go back a bit.
Range another, because we don't really know the size of this array. If somebody comes and adds in another element, let's say 23, the size is going to change.
What the hell is going on here? I don't think I understand.
And this may come in handy sometimes. Okay, let's comment this out. Another thing we want to see is that we can actually omit the size when we are declaring our array and initializing it. So here is a simple example. We have an int array called class sizes. We don't specify the size, but we initialize it. And the compiler is going to deduce the size of this array from the elements we put in here.
Okay.
So if we put in 2 elements, so it's going to be of size 2. If we put in 10 elements, it's going to be of size 10. And this is how this works. But if you do something like this and not initialize the array, let's take this out, for example, you're going to get a compiler error because the compiler now doesn't know which size it's going to give to this array. So be sure to either put in the size or initialize your array like this, and it is going to work. In this case, we're going to have 6 elements in, and you see that a range-based for loop is going to come in handy here because we don't really know the size of this array. If somebody comes and adds in another element, let's say 23, the size is going to change, and if we hard code the size in our for loop, the code is going to break. But a range-based for loop is going to use whatever size this array has. So we're going to try and build this. We're going to build with GC.
Range-based for loop. Read as for value in array. So for, and then this is the value in this. So, oh, okay. So it's reading. So so the value in this thing is whatever gets filled in here by the compiler when we run it, right? And if we change it, this invisible number that we haven't actually printed will be changed. And then it did. And if we run it, no, value will be 10, 12, 15, 11. So so value. So the the value is at whatever slot. Value is a temporary variable that copies the value from that spot in the array. Okay, the thing you printed. Yeah, I'm understanding it now. So like at slot 0, it prints the 10. At slot 1, it prints the 12. At slot 15, or at slot 2, it prints the 15. At slot 3, it's the 11. So it's going through this whole thing and just printing them. I like calling it a for each loop, even though it's not called that. I mean, it does kind of make sense. So this is for each value in this, right? And then it prints each of the values, quote unquote. It's not actually a command formally, but it is helpful. And then we could add, like, or we could even just take stuff away, right? And this would, like, we build this and it works exactly the same. Yep, works exactly the same. Can also be called an iteration. True. Makes sense. My God. So much power! Alright, let's put the numbers back in. 18, 17, and 23.
CC, as usual. And the build is going to go through, if we run rooster, we're going to get the elements. We have 10, 12, 15, 11, 18, 17, 23. If we add a new element, this is going to work. You see that we don't need to modify the loop here to put in the new size. And this is really cool. I like this about range-based for loops. We're going to build again. And we're going to clear run rooster, and this is going to give us exactly the data we have in the array. So this is one way you can do things. Another thing we saw is that you can't modify const arrays. So let's do an example here. For example, we're going to grab this thing and put an array declared down here. We're going to copy that and use that here, and we're going to make this const. Let's give it a name. Let's say birds, for example. For example, we want to keep track of lines of birds or whatever. This is just an example to show you that you can't modify this array. So if you try to do something like birds and index 2, for example, and you want to change this to an 8, the compiler is going to complain. You see that Visual Studio Code is complaining already. Expiration must be a modifiable value. So it is saying that the array stores const elements, so you can't modify elements of this array. Okay, so this is something you can do if you don't want people to be able to modify data in your array. And the last thing I'm going to show you is that you can do operations on the data in an array. So let's bring up our scores array again. So we're going to go up and copy it. Oh no, it's the math part.
Birds are just cool. I mean, I don't disagree. Arrays are allocated memory at compile time and their size is fixed, i.e. cannot be changed later. Yes. That makes sense. It's very rare that you need to loop for like every second step or similar. A classic exercise regarding arrays is to print a Fibonacci sequence. Oh god. Because that's like, what, 1, 2, 3, 5, fucking 8, 13. Oh, no, it's the math part, the guy learning programming. Look, shut up. Like I said, I'm an idiot. No one tell him about malloc alloc? What? What the fuck is malloc alloc?
The code is using it. So let's put in our own scores array. It's going to be pretty fast. And we're going to say that it is an array with this angle brackets. We're going to initialize this. Let's put in a bunch of values. And what we can do is sum these things up. We're going to store our result in the sum variable. And we're going to loop around with a range-based for loop because we don't really know the size of this array. It can change anytime with however many elements. And a range-based for loop is really cool in that we don't have to keep track of the size ourselves. So we're going to go in here and get each element and add that to sum. So for example, for the first time, sum is going to be 0 because that's what we initialize it with. We're going to get into this loop here. The first element is going to be 2. We're going to add that to 0 and get 2. We're going to add a 5. We're going to get a 7. We're going to keep adding these elements. And at the end, sum is going to contain the sum of all these elements in the array here. And this is one cool way you can sum up the elements in your array. So if we run this, we're going to get the sum printed out. Let's do that pretty quick. We're going to run this.
So this should just print out for you. Yeah, this should, so, okay. Element, scores, So this just goes through and adds up all of this stuff, right? Like I'm not misunderstanding that, and then it comes out and spits it all out. Terminal, run task. Wait. Oh, I fucked up. What did I fuck up? I fucked something up. Scores. Redeclaration of int scores. Wait. Redeclaration? Oh. Let me get rid of that. How about now? There. Oops. The Fibonacci sequence. Oh gosh.
It has to build with GCC, and we have ourselves a compiler error. What is happening here? It's going to say redeclaration of scores. Where did we declare scores before? Let's go up and make sure it is not declared somewhere, and it is declared here. So we want to
that's hilarious.
Come back to our code so that we can see
I got the same error.
And we're going to build again with
oh
GCC.
My God.
And now the build is going through. We're going to clear.
I thought for sure he had like commented out or something and I didn't see it.
Sum is 37. And if you sum these things up, I'm sure
and debugged before 37. The tutorial.
This is really all we set out to do in this lecture.
Score
I hope you
37?
have a better idea
nice.
of how you can declare your arrays, put data in, read data out of those arrays, make them const, or even do all kinds of operations on them. And this was really what this lecture was all about. We are going to stop here in this lecture. In the next one, we're going to see a cool way we can use to get the size of an array. Go ahead and finish up here and meet me there.
Okay, so that's size of an array. What's okay? So we're like halfway through this section, dude. We're fucking kicking ass. We're cooking. Pause it and uncomment the families part of the code. Wait, the families part. ¿Por qué? Let me do. Oh, whoops. Now make an array of different numbers and sort them. You have all the knowledge you'd need. What? Sorting them? What are you? What do you think I am? Some sort of fucking like savant? I don't know what the fuck I'm doing here. I have all of the knowledge I need. Now in cout, put I families. Wait. So I got 5 families. I'm going to comment out the score thing. Is that all right? Surely that's okay. I'm assuming we're not using that for this exercise that you've created. Like we're just using this part. It is okay. Lazy chose chaotic programmer. This is ancient, very cursed knowledge. Oh God. Okay, hold on. Let me clear out a little space for this cursed knowledge. I like cursed knowledge. I'm a very cursed knowledge, very big fan of this kind of thing. So what am I doing? So put in I families. You can see out. All right, let's do it like this. So we're just doing I families, like so. I family, a new feature of Apple can reprogram your children. Oh God. Why don't you reveal some cursed knowledge about the U.S. government? I don't have any anymore. It's been too long. Wait, this is class sizes. Oh, whatever. Inside loop. In the for loop. Wait, this thing? This thing? I'm a little bit I'm a little bit of an idiot. You have to go slow with me. Wait, actually, what the fuck does this do? iFamilies. What about the horror loop? Run it? Oh god. What am I doing? Wait, what? Families. So first it's printing this thing, which is just it's telling us what's in each one. Is this just printing the number? Wait, why does it do that? What the fuck? iFamilies is equal to families I? It's the same thing? Why is that the same thing? That feels backwards. It's the same thing, but in a cursed way. You need to know pointers to understand iFamilies. Oh my fucking god! I swear to God, we're gonna get to pointers like probably tomorrow, and then it's gonna be like this big thing that's been built up, and I have no idea what to expect from it. All I know is that apparently, if there's an asterisk, it has something to do with pointers. What the hell? These two iFamilies and families I is the same thing? Why is that the same thing? If it has to do with pointers, does it mean that it has something to do with like these two things? I don't know, pointing to the same thing, I guess? I don't know. What the fuck? That seems bizarre and wrong. Because, like, with this makes perfect sense, right? Families I. Because it's like, okay, so we're printing out the value that's at whatever section. You know, if it starts at 0, so we print out the thing at 0. It starts at we go to 1, it prints out at 1. We go to 2, it prints out at 2, etc., 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 all the way up until however long. This kind of doesn't make sense to me. I'm gonna DM you a good pointers for dummies site for tomorrow. You can also write asterisk families +1 instead of iFamilies. What? Families plus I. Not 1. I misread that, but this is the same thing? Hold on. I'm gonna just... So you mean to tell me that essentially... fuck it. I'm getting rid of this as well. All this text is fucking me up. These three things are the same thing? An array is just a pointer pointing to the first member of the array in memory. And I is the offset from the start, so it's basically just adding the offset to the starting address. This array knowledge is not really necessary to understand or even know. Only use it to summon the Kraken? What? Let him understand arrays for now? Hold on. I need to make sure. So... What? Why are these all the same thing? They're all exactly the same! What the fuck is going on? Why is it like this? What the fuck do you mean? Dude, this is... Yes, go on, continue with the lesson. I don't know if I can move on from that. Hold on, let me... Oh, holy shit. Okay. Let me real quick. Let me close this folder and open another one. I need to I I need to prep the next thing, I guess. Open folder. Another empty thing so that I can... Okay, get rid of this. Alright. I'm drawing a confused veggie face. That seems really apt for you right now. Dude, if I had emotes, I would be spamming it.
In this lecture, we're going to see a way we can query for the size of an array at runtime. If you remember, in the last lecture, we had an example like this, showing how we can declare an array and initialize it in a single statement like this. But the problem we had with this is that if we tried to print the array using a for loop, for example, we would have to use the size. And the size of this array may change if somebody decides to add elements or remove elements. Then the size is going to be irrelevant. C++ provides a way we can query for the size of an array at runtime, and we're going to get the real size accounting for the current number of elements that we have in the array. And for that, we use the stdsize function. This is a function that comes with the C++ standard library, so you're going to have it already if you have a compliant compiler. If you see here, you see that it was introduced in C++ 17, and it is a cool addition. We can use it to make our code easier to work with. If you look here, we have a simple loop which is going to print data out. It is going to loop starting from 0 all the way to the size of the array. You see that we use this to control when this loop is going to end. We then put in our incrementation part, and then we jump into the body of the loop and print the current element in the loop. And if we do things like this, we're going to be able to print all elements in the array regardless of the number we initialize it with. Okay, so this is one way, and it was introduced in C++ 17. But some of you must be asking, how did we do things before C++ 17? Well, we had to kind of do a hack to get something like this. We used the size of operator. We have seen a lot of times by now. And the way you use this, if you do size of and pass in the array, you're going to get the entire size of the array. So if we take that and divide that with the size of a single element in the array, we're going to get the number of elements of the array. And this is really what we are doing here. We are setting up a count variable, and we are taking the size of the array and dividing that with the size of a single element in the array, and we are just grabbing the first element because you can really use any element here. And once we have this, we can use this count to do a loop like this, and it is working pretty well. Please remember that you don't have to go through this craziness we're doing here. You don't even have to use stdsize, because you can use a ranged-based for loop and get access to the elements you have in the array, and it is going to work pretty well. Now that you have an idea about this, let's head to Visual Studio Code and actually play with this.
Be careful about ++i and i++ though. Oh yeah, because one of them will increment it before printing it, right? Or before using it in whatever thing you're doing it for. The worst thing about C arrays is that you have no dot length. I assume that that's a Python thing. I don't know what dot length is.
Okay, so here we are in our working folder. We are going to be working on this project, size of an array. We're going to grab our template project. We're going to copy the files and put them in place. And we're going to open this up in Visual Studio Code. Let's do that. It's going to open up in Visual Studio Code, and we're going to try and clean it up a little bit. And we are going to declare an array. If we want to print this thing, we need to know how many times we're going to loop and print elements in here. So one thing you might want to do is to say, okay, we have 10 elements in here, so I'm going to loop for 10 times. You might think this is going to work, and it is going to work. If we bring up a terminal.
Yeah, so this is kind of what we did before. I remember having to use I++ for loop and for loops to print an asterisk staircase in a class I took at uni. Oy vey. What the fuck? Vectors have dot length? What? Dot length gives you the size of an array. It's a thing used with different names and in many languages. That way you don't have to do that division thing. I don't know, man. The size of thing that we got in C++ 17 apparently is pretty good. that crazy division shit looked insane. It was like a lot of programming to just find how big an array is. It seemed like for one little thing.
And build this with GCC like we usually do, and clear and run rooster. We are going to get our numbers. This is what we have in the array
that we
from
did
1
in the
to
last
10.
one for this
But
part.
what if somebody comes and changes the elements we have in here? Let's add an 11 and a 12.
It suddenly doesn't work
the
anymore,
moment we
right?
change this,
Well,
we
it'll
will
print
need to
exactly
come and
the same
change the
thing,
size in here.
but it's not going to
this
print the
loop here
whole
might
array,
be buried
right?
somewhere deep in your project, and it might not be as easy as it is now to see that we also need to change this. This may be a really big source of hard to debug problems. So what we really need is a way to get the size of the array at runtime and be able to dynamically query for that size and use it in our program. And that's exactly what std size provides. So we're going to say int count, and we're going to put in a value. Let's use a braced initializer. So we're going to say std size, and we're going to pass the.
Let me put my stuff in so that it's similar to his. I've been mostly just following what the fuck the video is saying because I kind of understand, I think, at this point, arrays. 4, 5, 6, 7, 8, 9, 10. He has 11 and 12 in here as well, which is fine. Then it's int count, std size, and then I think it's the array that he's doing next, right? So scores.
The array we want to get the size for.
Yes, okay.
And if we do this, we're going to get this size here, and we're going to be looping for this number of times. So we're going to test for I is less than count here. And now it doesn't matter how many elements we have in here, we're going to get them at runtime. We need to only update this initializer here. So what we can do is build with GCC again. Now we're going.
Hold on. std cout scores. Oh, whoops. Gotta put this in quotations. Scores. And then it scores I. Or apparently I scores. Fucking weird ass. Weird stuff. Okay, let's see. So, let me see. Yep, there's also dot size or dot length with parentheses. Man is crazy with all those STDs. I've done a lot of good manga work this morning. Hell yeah, 30 minutes more. Nice. So, this should print the whole array no matter how many times, no matter how much we change it, right? That's kind of my understanding of what the purpose of this whole thing is. We create a variable that has the size of our array, which is decided at compile time. So, you know, if we change it, if we add more or take some away, it's exactly the same. Like it runs the same, and because I think we've gone over before that hard coding numbers tends to not be very good. Like, so this kind of makes sense to do. So let me build this terminal run task. I also need to open a new terminal because I have not. Yeah, so here it prints 10, so let's just get rid of like half of it. And build it again. Terminal run task. And we run it again. Alright. And then we go 9, 10, 11, 12. And we build it again. Task. And it's working beautifully. Works like a charm. This is incredibly convenient. I don't have to do that huge block of text to get the size of the freaking array. That's, oh god, what a time to be alive. I'm so glad I started coding after 2017.
I'm going to come here and run rooster, and we're going to get the numbers here. You see that we get all the elements. If we take out a few of these elements, let's take out a few of these. Let's leave in up to 7 or 8. Let's build again, and we are going to clear and run rooster. We're going to get however many elements we have in there. And this is pretty
convenient.
Cool.
That is
Again,
awesome.
You might ask, how did we do things before C++ 17? Because std size was introduced in C++ 17. Let's say that here. Before that, we had to get the size of the entire array and divide that with the size of each element in the array. And we could use the size of operator to do that. So before we do any of that, we want to play with the size of method to really show you what it does. So what we're going to do is say std cout size of scores, the entire array, and we're going to print that. And we're going to say std cout
arrays are the big gateway that unlock everything. What do you mean by that?
One element. Let's say scores, and use the first element. This is the easiest thing we can find here, but you can use any element. So we're going to say size of here, and we're going to say scores, and grab the first element, which is at index 0, and we're going to print its size. If we build and run this program, we're going to build and run, and the build is good. We can clear now and run rooster. You're going to see that you're going to get size of scores is 32, the entire array. The size of one element is 4 because we are storing in integers. And I want you to see that 32 is 4 times 8 because we have in.
Oh, no fucking way. You mean to tell me you had to manually figure out how, like, you had to divide how many fucking bytes were being used to figure out how big the array was? Fuck that. No way, dude. That sounds insane.
8 elements. So it's going to give you the combined size of all the elements that we have in here if you do size of an array. But if you do size of a single element, you're going to get the size of a single element. So C++ developers were clever enough to see this and see that we could use this information and get the count of elements inside.
That.
So we can do something like int count, and we're going to assign a value to this in our braced initializer. So we're going to say size of, we're going to say scores, and we're going to divide that with size of, and we're going to grab scores. We can really use any element in the array, but we're going to grab the one at index 0. And now we're going to get the count stored in our count variable without using std size, and we can uncomment our array here or the code to print the array. And if we run now, it is going to work exactly the same thing regardless of the amount of elements you have in here. Let's put a few numbers randomly, and if we build and run, we are going to clear and run rooster, and we're going to get all the elements in here. And you can really use any of these techniques. Just choose what you
Oh
feel
my
works
God.
better for you. Okay.
This is insane. I mean, it's incredibly clever. Whoever, I guess, came up with this, whoever publicized this, made this common knowledge is like a freaking genius. But geez, dude, that is nuts. Did he just say breast initializer? I don't think he said breast initializer. Imagine trying to program splash damage in a game and you have to manually type in guy health 1 minus 5, guy health 2 minus 5, guy health 3 minus 5, and so forth. With arrays, you can just use a loop. Jesus. Instead of doing math, I usually did 4 int I 0. I is less than size of scores plus I plus. How goes you floats? It's going all right, Steve. It's going all right. I'm getting my freaking brain expanded here because arrays are kind of insane. Look at what they have to do when we can just do this now, or this thing, in order to figure out how big our arrays are. This is a lot more work. This is a lot more work than what we're doing over here. this is this this is like this is comically more. I mean, I guess it's like, if we're not, like, Lazy says, we're not going to use arrays that much, but, I mean, still. Instead of doing math, I just scream at God. I would probably just copy and paste something from the internet, like, hey guys, how does this work? Oh, it works like that? Alright, let me just, yoink. That's probably the easiest way to deal with, complicated, difficult situations like this. And then you find out, oh man, that was proprietary, I wasn't allowed to do that.
Okay, we are going through all this trouble to set up an iterator. We're going to do the test. We're going to increment. This is really too much work to try and get data from a collection like an array. So what we can do instead is comment out all this hard work here, and we can use a ranged-based for loop as we have seen before. And it is ridiculously easy and convenient to work with. So what you can do is say for auto we're going to do type deduction on whatever it is we have stored in our array. So we're going to put a column and say scores, and we're going to print out the element. So
actually, I should probably should I do? Is it worth typing all this stuff out? I actually don't know if it is, because this isn't stuff that we're. I don't think it's something that I'm gonna actively use. Anyways, not yet. Are vectors linked lists? I forget. Vectors are arrays, but they have so much quality of life built in. It's insane. Really. Can't wait to get to those in. Well, I mean. I'm sure it's in there somewhere. I have no idea where vectors would be. Is it at the end of this chapter? No way, right? Yeah, this is array of bounds. Okay. Let's get our... Alright, let's comment our shit out. Do bump bump. Bump 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 ba-da-dum. No, they're just dynamic arrays.
So let's do that. We're going to print stdc out, and here we're going to say value. Let's say value in the array, and we're going to say I. And this is going to print all the elements, and we can work with the values inside if we want that. But you see that we have lost the information on the indexes. So if you really need the indexes, you will need to go through something like this. And if you just need the values in the array, ranged-based for loops are going to be
use
really
array
cool.
to
Let's say
describe any structure you can loop
and if
through.
we build and run this, it's going to work pretty well. So the build is going to go through. Let's bring this up so that we have some breathing room. We're going to clear and run rooster. And we're going to get our elements printed out here. And you see that it is the exact same thing we have in scores here.
Wait, what? Hold on. Auto, for each I scores. There's no way. Wait, is there something that I'm missing? Huh. Nothing that I'm missing. Scores. Oh, okay. Yeah, okay. For each scores auto. And it just goes through the whole list. I don't know why this is here. This is the range-based for loop again. I need to really familiarize myself with this. I think the syntax here is kind of confusing to me. I understand what it's doing inside of it, right? It's just printing out each value, or I guess each part of it. But this syntax, I need to get used to, I think. Actually, it's indices, not indexes. Almost had to implement a linked list once. Decided to use maps instead. Wirt. I need to get back into messing with Python code sometime. I was last working on experimental GPS tracking stuff. That'd be cool. Just don't like track my location or anything. That would be no go. Oh, let's see. So, I think the thing that's throwing me off is this is what this auto is doing. Because like auto I, so integer scores tracking your balls. Value I. This is our thing. Auto is for when you don't know the type or are just lazy. Yeah, I mean, when we covered auto, we went over some ways where it could go wrong. Like it was like basic math stuff. Like, oh yeah, like auto. Uh, I think it was storing doubles as an integer or some shit. To be type safe, never use it. It's a risk potential you can completely avoid. I mean, I'd probably avoid using it generally, just because I like knowing exactly what the fuck I'm doing, but it is apparently also helpful. Why does it say Taro's location is in this weird underground pit of fire? You know, we don't think about it too hard. Yeah. Let's keep
So
going.
this is really all we set out to do in this lecture. I just wanted you to be aware of the STD size facility that we have in the C++ standard.
All right. I kind of want to, so since that's the end of that one, we're going to go into the next one shortly, but I kind of want to see, we're going to do this. I kind of want to see how this other thing see out. And this is the size of, god damn it, I can't fucking type. Scores. And then we do our size of scores. STD inline. STD see out. Size of scores 0. And then we do our size of scores 0. STD and L. Be aware of the STD size, get it checked. He's pogging out. Auto fellatio, get it checked. Big STD sentient, oh god. What is this doing? Where is it expecting the semicolon? Oh, is it because I haven't bit shifted it? Yeah, it's because I haven't bit shifted it. And then we do, this was int count size of scores divided by size of scores 0. Big STD have names and social security numbers. Oh, hold on. That's a little bit awkward. And then this, when we run task, this was the old inefficient way. And so with this, our array's size is 12, right? So yeah, it just counts up to 12. Wow. And then our count becomes, when we go through, well, yeah, we could put in this again, right? And go to count, and our count would be, let me copy this. Instead of just theorizing about it, what we can do is test it, right? For size ti, so this should work, right? Initialize the I here. Our scores is still the same. And then count is whatever we've put up there, so terminal, run task. And then it prints it out exactly as we wanted. Okay, so that's, I mean, this is an ingenious way to go to solve the problem that of not having a size. What was it? STD size is what it was, right? Because STD size was the one that is more efficient to do the exact same thing. Do like so. This is, call this old way. And then this one, yeah, just call this C++17 way. And in parentheses, STD size. Not in parentheses, because that confuses me. I'll do, I guess, this thing. Okay. This is this is really interesting. I'm like, I feel like, okay, so not gonna lie, I feel like I've just been staring at this silently for like several minutes, and I don't actually know. I've lost track of time. What the fuck is going on?
Library. If you don't want to use it for any reason, you can also go in and do the division we did here to get the count of elements in the array.
This is important to keep track of, to remember for future potential problems,
because they make it easier and cleaner to get data from a collection like we are doing here with an array. We are going to stop here in this lecture. In the next one, we're going to see how we can work with arrays of characters. Go ahead and finish up here and meet me there.
Arrays of characters, let's go.
In this lecture, we're going to work on an array of characters and show how special they are. You can declare an array of characters just like any other array. So here we have an array called message. It stores elements of type character. The size is 5, and we initialize it with a bunch of characters. If we want to print it out, we can loop like we loop through any other array. In this case, we're going to be using a ranged-based for loop. We say for auto C, we pass the message, and then we're going to be printing each character
out?
in the message. And if we do this, we're going to see hello printed out on the console. We can also modify elements in our array. For example, we can say message1 and change the E here to an A. And if we print out, we should see hello printed out on the console. Nothing really special so far. The cool thing you can do with character arrays is that you can print them to the console directly without even doing the loop. you can do something like this. You can do stdc out, you say whatever you want to do in quotes here, and you're going to print the message. But sometimes this won't do what you expect because only proper C strings can be printed on the console. And what makes up a proper C string? A proper C string has this thing you see on the end here.
I dislike it.
This
Can't remember the last time I used
/0
char.
is called a null termination string. And it is what is going to tell C++ that we have hit the end of the string and we are going to stop printing it if we are printing with things like stdc out. So this is really important to be in your strings. If it's not there, it may work, but sometimes it's also going to print some garbage characters after this, because what tells stdc out that we have reached the end of the string is this \0 here. If it's not there, it's going to keep printing until it sees one, and then you're going to probably have some garbage characters added to your string, and that's not what you want. So to have your strings printed out correctly, be sure to have in this null termination character here. And if we print it out, we're going to get it, and we're going to see the size printed out properly if we
Garbage
do things
characters,
like this.
tag your friends.
But it is possible to get this auto-filled for us. If you look here, we have a character array called message2. Inside we have said that we need 6 elements, and we say hello. So we have 1, 2, 3, 4, 5 elements, and the elements we don't initialize properly is going to be initialized with a 0 version of a character. And that happens to be the null terminator of the null termination character. So this is going to print correctly, and we're going to have the \n appended to this for us by the compiler. But be sure you understand the difference between this and this. Here we have specified the size to be a 5, and we are putting in 5 elements, so we have no null character appended to this string. But here
So
we have
need
said
a
that
null
we can
character
put in
appended
6
to the
elements,
end of a
and we have only put 5, and the
array of
compiler is
characters?
going to autofill in the null terminating character. These two things are different, and make sure you understand the difference. Okay, so now take a look at what we have here. We have a string, we didn't specify the size, and we just initialize it with hello. Someone might think, this is also going to autofill, but it's not, because the compiler is going to deduce the size of this array using what you initialize it with. And you didn't put in a null character, so it's not going to be accounted for. You're only going to have this here, and if you print this out, you may get garbage characters appended to your string here, so be careful. But it is possible to do literal C strings and only say hello like this in quotes, and you're going to get the null terminating character appended to your string here. So if we
So why does this append the implicit other one? And when you had them separated out by commas with single quotes, why did that do that? Oh God, this is going to be so confusing. Let's hope that this makes more sense as we go along and get to practice it.
we print this is going to print nicely, and this is the recommended way to initialize your character arrays. If you want to put in string data like this, you have to use double quotes. And the cool thing about this is that you can even put
So
in
the double quotes
spaces
make the
between
implicit,
words like this. It is going to work. This really looks like how you would
Single
like
quotes
to
also
type
appended?
text and store that in your character arrays. And we're going to be using this a lot in the course. Again, I want to bring to your attention that character arrays are special in that you can directly print them on the console like we are doing here. You see, this is a character array, and we are saying stdc out message 4. You can't do this with other arrays, and this is really
Personally,
all I
I'd skip
had to share
characters.
about
You will
character
always use full
arrays.
strings
So
in
what we're going
normal
to
game
do next is head to
I'm just
Visual
gonna
Studio
I'm
Code
following
and play with
exactly.
us. Okay, here we are.
I'm
in
afraid that there
our
might be something
working
important
directory.
that I
The
miss.
current project is arrays of characters.
I've jumped
We're going
ahead
to grab
before,
our
and it's
template
always
project,
fucked me over.
and we're going to copy the files, bring them in here, and we are going to open our folder. We're going to open the main CPP file, and we're going to get rid of what we don't need here. Let's put in some starter code so that we can start playing with this without typing this too much. So we're going to declare an array of characters. It's going to be called message. The size is going to be 5, and we're going to fill it with characters like this. So if we do this, we might want to print it like we print any other array. We're going to use loops, and in this case we chose to use a range-based for loop. So we take auto C for character in message, and we're going to print out each character. Notice that we're not adding stdendl here because we want the characters printed close to each other so that we can read this easily. And after this, we will need to go to the next line so that the next thing we print doesn't disturb us. So we're going to say stdcout stdendl. And if we do this, we're going to see hello printed out on the console, but we had to do too much work to print something simple like hello. But let's do this. We are learning. So we're going to bring up our terminal and we're going to build with GCC. Let's do that. The build is going to go through and we're going to clear and run rooster. You're going to see that it's going to say message is hello, and this is what we expect. And this
What the fuck? Okay. So this one's just an empty line. That's fine. So from what I'm understanding, is this not just a more complicated way to just type something here? Is there a reason that we would use a character array to print text? It sounds like an awful lot of work for not a whole lot of payoff. I mean, I guess you could change individual things in here and have it print different things, but you still had to declare an array for it. Strings were invented after chars. Is that why? Is that actually why? Like, in order to print a string like this, before you actually had to go through this whole process of using character arrays, as it were.
This is really how you would declare an array of characters and initialize it with whatever it is you want to initialize it with. But you notice that it's really not convenient to put data in here. If you want to store a message, for example, for someone, you don't want to do this thing you see here. It's really ugly, it's inconvenient, and nobody would definitely use your program if you required your users to type things like this.
Yeah,
so we need
is
to
insanity.
change this, and we will. But before we get there, let's also see that we can change characters in our array. So if you look here, this E here is at index 2. So what we can see,
char is ASCII. You can assign like 96 to a char variable and it'll print an A. Well, yeah, we actually did actually see that in like early on my stream. I like he demonstrates why the like why you can't use char or whatever the fuck it is for certain values, right? Or like why you would do integer char versus double and things like that. And like one of the things that we saw is that ASCII is that we saw like the ASCII code. I'm gonna dip for a while to do some Japanese grammar. Understandable, man. Get some rest. Fuck me. Have fun with that. But it seems like, but like, but why would you do this? This seems like a lot of work. All right, let's change characters in our array. Are you on strings? We're on arrays of characters, which I guess is a kind of string. It's fucking...
It's a message, and we're going to target the element at index 2. Oh, it's index 1. Let's use that. So this is index 0, the H, and the E is at index 1. Let's make sure we get this straight. And we're going to store in an A in quotes. Remember, characters are surrounded by single quotes like this. Once we do this and we try to print the array out again using our technique here. We're going to copy the code and we're going to paste it down here just to do this simply. And if we...
Oh, am I an idiot? I think I'm an idiot. Whoopsies. Hold on. That, and then... Yeah. It's just the printout array through looping. Yeah, so this should... If my understanding of this is correct... I feel like learning char is just for historic reasons. Unless you work on science or military hardware where every bit counts. I mean, I do have one friend who works on, like, space robots and shit. So, that's interesting stuff. And he's told me, I think I mentioned it to you, Redbird, that this guy uses, like, Fortran and C++ and, like, punch cards and shit. So this should print hello and then hello. Look at that.
do this, we're going to see the message printed out here to be hello. And the second message is going to be hello with an A because we changed the second element to an A. It's no longer an E. So that's what we expect. We're going to run the task to build with GCC. And we're going to bring this up and clear. And we're going to run Rooster. You see that we have message hello and message hello. And we are able to print things successfully. This is really cool, but we are doing too much work to print something on the console. And there should be an easier way to do this. And there is. So what we're going to do is comment this out because we don't want noise output in the console when we try to do something else. So what we're going to do is comment out all we've done so far. We're going to leave in our message here, and we're going to try and print it directly on the console. So we can say stdc out and say message, and we're going to print out the message. And take a moment and look at this and try to compile this. It is going to go through, it is going to compile because C++ supports printing character arrays like this, but in most times this is not going to do what you expect. Let's try and run this and see what we get. We're going to run Rooster, and you see that we're lucky to get something that really isn't what we expect. It's printing hello, and you see that we have a bunch of other things, and the reason is what we have discussed in the slides. For character arrays like this to be printed out properly on the console, they need to be null terminated. In other words, they need to have the null character, which is a \0, appended to the string for stdc out to know that it has reached the end of the string. So this is what makes your character strings legal. Now you see that we are getting a compiler error because we have overflown the size of the array. I think that's the message, too many initializer values, and this is exactly what we have done. Now we can try and change this guy to a 6 to say that we have 6 elements in here. This squiggly line should go away. And if we try to build and run, we're going to build with GCC. Let's bring this up a little bit. And we're going to clear and run Rooster now. And you see that now we have hello printed out correctly. If we turn this back to 5 elements and take out the null terminator, we're going to try and build again, and we're going to clear and run Rooster. You're going to see that we get the garbage back. So for your strings to be printed out correctly, they need to be null terminated. That's why it is not safe to print something like this when your character array is not null terminated. I really want you to understand this. So in C++, we have a proper name for these strings that are null terminated. A null terminated string is called a C string because these things come from the C programming language. Okay, and we're going to see a few ways we can set up C strings now. And the first one is to say car. We can call this message1. And it's going to be an array of characters, and we're going to initialize this with hello. Let's copy this because I don't want to type all these things here. So let's copy this, and initialize this properly. Notice that we didn't specify the size, so the compiler is going to get the size from however many elements we put in here, and we're going to put in our null terminator here, and if we print this, this is going to work. And we are going to comment this out, and we're going to say that this will give you garbage. Okay, if we come down here, we're going to see that we have a car array. It is called message1, and we have initialized it with data. We have hello, and we have a null terminator here, and the compiler is going to reduce the size. So this is going to be a proper C string, and we will print it correctly. Let's try and build this. The build.
My God. This whole section has been fucking, like, it seems a little archaic. What is this? Oh, it's not in its quotations. Whoopsies. That explains why it was being strange and weird and didn't like me. So we have that, and then this is message 1, and this one is message 1. So this is a C string because it's null terminated. This one is not a C string. And I'm just gonna comment it out. And is probably not not the way that I'm going to be doing this in the future.
Is going to go through. If we clear and run roster, we're going to get our message here, and this is one way we can set up a proper C string. The second way is to actually not put in the null terminator, but let the compiler add that in for you. And the way we can do that, we can say car message2, and we're going to say this array is of size 6. Let's say that. We're going to put in a 6 and fix how we end things here. We're going to put in our quote and end this with a semicolon. Now what is going to happen is the compiler is going to see that this array is of size 6, but we are putting in 5 elements. So the remaining slots are going to be autofilled, and it is going to be using null terminators to autofill this then.
Oh, I am messing something up. Where's my thingamajig? Type error constant. What have I done? Message 2. Why is all of this in message 2? We're making this 6, and we're taking these out. I don't know what I changed, but it changed something, and that seems to have fixed my problem. O is missing a... Oh, I accidentally deleted this one, probably. Whoops-a-daisy. Get yourself a thing that counts how many days have passed since you used char and tell me the next time you need to reset it. Sure. I'll, That's fucking hilarious. It's like, yeah, the next time you need to use it, let me know. Here. So currently we're gonna go based off of just the day, I think. So it is August 13. I will send you a message the next time I need to use character for something.
If we try to print the size here, we're going to get a 6 because the null terminator is added in by the compiler. Let's try and print the sizes here actually so that you can see these things. So we're going to say size, and we're going to say that size of message 1, and we're going to put in a new line character, and this should be what we expect. So what we're going to do, we're going to copy this and put that down here because we're going to be doing the same thing for message 2. So we're going to say message 2, let's select this, and say size of message2 and do size of message2. So what we're going to see is message1 and message2 printing out, and we expect to see a size of 6 because both of these guys have 6 elements inside. So we're going to run the task to build with GCC and bring this up, clear, rooster, and this is exactly what we expect. Message1 is hello, the size is 6. Message2 is hello and the size is 6. And these are a few ways you can declare your character arrays and initialize them with proper data that is going to print correctly with stdc out. Make sure you don't do something like we did here by printing message here because it is not null terminated. This is going to give you a lot of problems. Again, I want to make it really clear that message3 here is not a proper C string because the compiler is going to deduce however many elements we have in here, and this thing is going to be of size 5. And we're not going to have a null terminator, and if we print it out, we're going to get some garbage. So let's try and copy this so that we are consistent with what we've done above here. And if we compile with GCC, we are going to compile successfully, but we may get weird things if we print out message3 like we do here. And you're going to see that the size is 5 because we only have 5 elements in here. So let's clear and run rooster, and you're going to see that we have hello for message1, we have hello for message2, but for message3 we have things we don't expect because it's going to keep printing and it's going to go overbound and it's going to stop when it hits the first null terminating character like what we have in here. Okay, so
I think it's interesting that, so with these other ones, right, we could see this is complete garbage, right? This is garbage. It's nothing. But with this one, with message 3, and this is on his code as well, it's hello, hello. I think that's kind of a neat, I guess, error, bug. I mean, that's why it's, I guess, it's a fucking, this one is a, not a proper C string. So do like that. Because I mean that is the whole reason for this. So these two, let me clear this and then run it again. So like these two are, they work exactly as intended. They have the right size. They're, I mean, they're correct, essentially, right? But this has more text than it's supposed to, or more text than, I guess, our intent would be, assuming that this was a mistake or a bug or whatever it is that we're trying to figure out that something's wrong. And it also is just because we're not using the null terminator, it doesn't have this is caused by this, essentially. Not a bug, a feature. I mean, for us it's not a bug because we're doing it to recreate the issue. Right? Like I guess, but like the assumption is that this is what we're, the assumption is that this is our intent as the developer of this software, right? We want it to print these messages, and this one would be an incorrect, like, oh, something is wrong. But because, I mean, that's pedantry, I think.
So this is not safe. Don't do it. Make sure your strings are null terminated if you intend to print them with stdc out like this. Okay, so working with character arrays like this to print messages and do all kinds of crazy things is nice, but it really isn't convenient. As I said before, you wouldn't expect your users to type characters like this by surrounding them with single quotes. This is really ugly and it is painful to do if you want to do some productive work. So C++ allows you to use what we call string literals, and we're going to see an example of that down below. We're going to say string literals, and what we can do is car message for. It's going to be an array as usual, and we can initialize it with a string that is surrounded by double quotes. And what this is going to tell C++ is, take these things, break it into characters, and store this in this array here, and make sure you properly null terminate this string here. So if we print the size of message 4, we're not going to get 5, we're going to get 6, because C++ is going to see these double quotes and know that we intend for these things to be properly null terminated, and it's going to add a null terminator. So let's try and print this out so that we really are sure. And we're going to build this with GCC as we always do. The build is going to go through. Let's go up and clear, and we're going to run rooster, and you see that message 4 is hello, and the size is indeed a 6. So this is one way we have to do things, and we can even put spaces and do all kinds of crazy things, and it's really cool. And if we try to build this, we're going to get the proper message printed out. You see the build is good. If we clear and run rooster, we're going to see hello world, how are you doing? And this is really cool. So from now on, if we need to store a string in our program, this is how we're going to do it, because this is much more civilized.
So wait. He says from now on, if we need to store a string, this is how we're gonna do it. Does that mean that all of this nonsense is gonna go away? Because somehow I doubt that. Right? I mean, I guess if we have to store a string for some reason, we're using it somewhere, right? We haven't actually done anything with that as of yet.
And it is how you would really like to type characters in your program. I have said that character arrays are really special because you can directly print them out with stdcout like this. I want to prove this, so we're going to try and declare another array. So we're going to call this numbers, and we're going to make this an array, and we're going to initialize with 1, 2, 3, 4, 5. This is going to do, and we're going to put our closing semicolon, and we're going to try and print this out. We're going to say stdcout and say numbers. Let's see what we get. Let's try and compile this and see what we get. It is not actually going to give us a compiler error, but it's not going to print what we expect. And let's put a message here so that we know that it is this thing we are seeing here. So we're going to say numbers, and we're going to put a colon here. And we're going to build this with GCC, and we're going to clear. And if we run rooster, look out for the output that says numbers here. So let's run rooster. It's not a 1, 2, 3, 4, 5. It's something we don't really know.
Hold on, I fucked something up somehow. Oh, there's no bit shift. Duh. Yep. That was our problem. I keep forgetting those for some reason. I don't know why. That doesn't seem to be what I thought it was gonna be. This is something in hex. BDA 89 FFC 70. I'm sure that means something to somebody. Maybe Gakwaya Sensei will tell us.
Oh, and we will get to understand what is happening here in the next chapter. For now, know that you can't directly print arrays other than those of characters. If you try to do that, you're going to get weird numbers printed out.
Interesting.
And we're going to understand why this is
numbers
the next
and
chapter.
not.
So let's say that here. Okay, this is really all we set out to do in this lecture. I hope you found it interesting. Character arrays have a few things you need to be careful about, and we try to cover those in this lecture. We are going to stop here in this lecture. In the next one, we're going to try and look at array bounds. Go ahead and finish up here and meet me there. In this lecture, we're going.
I'm kind of curious. How much more of the? array bounds. Okay, so this is the last section, and this is apparently pretty short. So let's I'm gonna go ahead and comment all of this out, and this is gonna be the last section that we do today. This has been a very enlightening lesson, I think. I think arrays are kind of they're I mean, I'm not gonna lie, I was super nervous going into it, but it seems much more simple than I initially
To
believed.
look at what could happen if you try to manipulate data out of the bounds of your array. We have seen that when you allocate space for an array, the computer is going to give you a bunch of
It's the
memory
address to the first
locations you can use to store
number
your
of
data.
numbers.
And
Addresses
it's going
always
to
start
be
with
of the
LX.
size that you have specified or that is deduced by the compiler. So here is an example of an array that is going to store 7 elements. And we have green slots for these elements. And these are the locations we are allowed to manipulate in our C++ program. If we try to go overbound, for example, if we try to modify something before our array or after our array, it might be a memory location that is owned by another program. It might be a memory location that is even being used by the operating system. So bad things can really happen if you try to use data that is outside the bounds of your array. Let's try to look at a simple example here. Here we have an array called numbers. We have 10 slots inside. So we are only allowed to modify the memory locations for these 10 numbers. And if we try to access something outside the bounds of this array, something might happen. But some people say that C++ is really funny because it should be stopping you from doing something like this. But C++ allows you to do this. If you look at code here, we have an array, we have 10 elements in, so the valid indexes we can really use are from 0 to 9.
Right.
But if we try and access something at index 12, the code is going to compile, and if we run it, we're going to get something printed out. But that's something, this is going to give you garbage data, or you might be even trying to read some restricted memory, and your program is going to terminate immediately, and we're going to say that it has crashed. If you try to write over bounds, the compiler is also going to allow it, but you don't own the memory, so other programs might come and change that memory location, and if you try to read from it again, you're not going to get what you expect. Another thing that could happen is that you try and modify data that is owned by other programs, and you might imagine how bad that really is. So the message here is don't go over your array bounds, and you're going to be playing in the safe zone. Let's head over to Visual Studio Code.
Right beyond bounds. The compiler allows it, but you don't own the memory at index 12, so other programs may modify it, and your program may read bogus data at a later time. Or you can even corrupt data used by other parts of your program. Yeah, what are you meowing at? So that sounds a little bit I mean, it sounds a little bit scary. Like, I don't think there's any way that I break my there's no way I brick my computer by fucking up an array, is there? Like, I'm not gonna accidentally delete system32 and like spawn a fucking .bat on my shit that will just like nukes my computer. There's no way that happens, right? That's like only in my worst nightmares. Like, oops, I accidentally opened a zip bomb with my Neuralink, and now my brain is overheating.
Code and play with this a little bit.
Yeah.
Here we are in our working directory. The current project is array bounds. We're going to grab the template files, and we're going to put them in place. And we're going to open this up in Visual Studio Code. We are going to declare an array and try to read beyond the legal bounds of our array. So let's try and bring up a terminal here, and we are going to build this with GCC. The build is going to go through. You're not going to get a compiler error, but if we run this, we can really get anything. And you see we have a number. We don't really know what it means. And this means that you have read out of the legal bounds of your array. And C++ allows you to do this, and the reason they do this is because they expect you, the developer, to know what you're doing when you try manipulating things like array. And now you know this, and be careful
Wow, they
when
really
you
just
are
said
working
it's a
with
skill
arrays
issue.
like this. So don't go over bounds, that's the message. We may also try to modify data beyond bounds. So let's go down and put in the code to modify things, and I have put a clear message here as a comment.
Okay, let's... I kind of want to see. Read beyond bounds. Will read garbage or crash your program. And then this one is right beyond bounds. The compiler allows it, but you don't own the memory at index 12. So other programs may modify it, and your program may read bogus data at a later time. Or you can even corrupt data used by other parts of your program. You have RAID? Wait, what? I have a RAID? What are you talking about? What does that mean? Wait, what the hell? Hello. Sorry, I have no idea what's going on. I am, I am learning. I'm trying to learn. What is going on? RAID. Oh god, I don't have YouTube, settings for any of that stuff. I don't... It's funny because I have all of my notifications and stuff on like Twitch, but I don't think I have many viewers there. Lel. Bogus? What's bogus? Are you fucking with me? Is that what's going on? Numbers 12 equals 1000. And then this is std cout. Numbers. He mispronounced read as raid. Oh, Jesus, dude. Going to raid. You fucked with me. You fuck on me! Alright, numbers 12. And then std and l. We call that foobar. Fucked up beyond all recognition. Alright.
To let you know that this is really something you should be very, very careful about. So we're going to try and change that number to 1000, and we're going to try and print it out and see what we get. But this memory location at index 12 is not something we own. So other programs might come and write to this location.
That's a good sign.
And if we try to read from it again, we might not get what we put in here. Even worse, this memory location might be owned by other programs, and if they read, they're going to get what they didn't put in, they're going to get what you put in, and this is something bad. We might try and really go crazy with this. Let's put in a really huge number.
Oh god.
And see that we can do that. This is a good way to learn, by the way. It's going to compile, and let's try and print what we have in there, and we're going to say this location here, and that's what we're going to say here. And we're going to build. Again, the build is going to go through. You see that we are doing something really crazy. Our array...
Oh, hold on. I didn't read that. Run task. Build finished successfully. This doesn't look like it's doing anything crazy.
It has 10 elements, but we are trying to modify something 1 million memory locations away. And this is really crazy, and C++ allows you to do this. So let's clear and run. Did we build? Let's make sure we have build. So let's build with GCC.
If I suddenly get disconnected, you know exactly what happened. It's my shit
Our program
exploding.
is crashing because we are trying to access something. that isn't really ours, and you see it has crashed. Okay, for example, if we have something printed out.
That's interesting. It's interesting to me that it printed, and then when we modified it, it printed the exact same thing and didn't actually change anything. That's probably the best case scenario.
After this, let's
I'm
say
gonna stop fucking with that.
program,
I'm a little bit worried
and
about
then
that.
so that you can see it is really crashing, and say stdndl. This statement here is not going to.
You didn't put in the
print.
999. Well, yeah, but it's still out of bounds. It's not like that far out of bounds, I guess. I mean, I can change it. What is it? 1, 2, 3, 4, 5, 6. Here, minus one of these. This is 1,299,999. Also, you used equals instead of equals. Oh, did I? Oh, I mistyped that. Whoopsies. Terminal. All right, fine. Well, so this time this one went and then it crashed. Way out of bounds. Way out of bounds. There. Good.
Because once we hit this location, we're going to try and modify this, and the program is not going to be able to do that. It's going to crash. The operating system is going to notice that we are trying to do something crazy, and it's going to say, this program is really crazy. It doesn't know what it's doing. I am going to kill it, and it is going to stop. That's basically what is happening here. So let's build again with GCC, and we're going to clear. Let's clear. And run rooster. You see that it's going to try and do this. It's going to try and put a value in here. The program is going to end here. And this is really bad because memory locations you have allocated for before here are not properly released and returned to the operating system. And this is something really bad. So the message is, don't go over bounds. Make sure you are working within the legal boundaries of your array. Welcome to this new chapter.
Oh, okay. Okay, so we're gonna go ahead and I'm gonna write a big ol' warning for myself. Do not do this. There we go. Because I need extra big capital numbers and letters. Yes, capital numbers. They're brand new. They just came out with the Earth update 6.3. It's yeah. Okay, cool. I got 1,299,999 problems, but a char ain't one. All right. So, that was the entire chapter on arrays. Very enlightening chapter. I did think that the arrays of characters thing was a little bit, it seemed a little bit weird to go over it. I'm sure there is a reason for this. I'm sure there's a reason we can use these in the year of our Lord 2024, but that is that is it for now. Pointers, he's pointing. Yeah, I'll be pointing tomorrow. So wow. I'm actually kind of surprised by that. So now we got what? So pointers looks like it's going to be a pretty long chapter. I might have to do pointers over 2 days, depending on how long this goes, but the video goes for 3 hours on pointing. So, and given that this, I mean, we're coming up on 2.5 hours, and this is only barely over an hour an hour and some change. So odds are pointers will be a 2-day event, but we will be doing it this week. We will complete it this week. So it's pretty good. That's pretty good. So I'm gonna go ahead and close all this stuff out. Boop boop. Oh wait, hold on. I gotta go to my. I have a dot text with my shiznit. Chapter 7. Wait, we just did chapter 7, right? Yeah, chapter 7. So we're going on to chapter 8. Fucking pointers, baby, yeah! Okay, there we go. That makes me happy to see that. Pointers are something you don't understand, then yes, then no, then yes, then no, then maybe. They are hard to understand. Oh, boy. Well, if they're hard to understand, then I suppose that's just gonna... I'm gonna have to figure it out one way or the other. That's kind of why... I mean, you've seen me go through on much simpler concepts and like just go backwards. Like I didn't understand that. I need you to say that again, but slowly. I need you to say that, but in a way that makes me that makes me understand it. Maybe if you speak in a higher pitch, maybe if you wear these thigh highs, maybe if you you know any number of different things that may or may not help. But yeah, so. That was a pretty good day, I think. Arrays are an incredibly interesting. I say incredibly interesting. They're very interesting in that like I they're a programming concept that I wasn't actually like familiar with. Like a lot of the stuff like for loops and ifs and binary like booleans, not binary, booleans and stuff like that. I've heard of before or covered in like high school fucking however many years ago that was now. And like it's not totally unknown to me. Arrays were something that I don't think I've ever messed with them before. So this was a first experience for me. Just tell me to wear the high thighs, why the excuses? I mean, I just want to understand things better. Okay, if the thigh highs help you explain them better or helps me understand better, then you can wear them. I would encourage it even. But but anyways, this has been that's 2.5 hours of programming. I'm gonna go ahead and we're gonna call it an afternoon here. I'm gonna get some dinner, some food, some drink, and then we're gonna I'll be back later tonight at around 11 p.m. my time, so that's 5.5 hours from now. And we'll be playing some more Misadventures of Tron Bonne. That'll be some that'll be fun. I hope you guys enjoyed hanging out with me. I enjoyed hanging out with you guys, and I'll talk to you guys later. I hope you see. I hope to see you again soon. Good afternoon. Don't die by strangulation. I won't die. I can't be killed. I'm immortal. Anyways, guys, have a good one. Bye.